Let's talk about vertex form and how to get a generic quadratic into vertex form. So if you think about f of x is equal to x squared, and let's say you did something like x minus 3 quantity squared, the vertex to start on x squared was 0, 0. Well, now I subtracted 3 on the inside, so I'm going to add 3 to the x, so my vertex is now at 3, comma, 0. If you then say, multiply by 4, out front, that would be a vertical stretch of 4, so my vertex is still going to be at 3, 0. My graph would just be stretched vertically more. And then at the end, I do one more thing. Let's say I add 7. And then my vertex is now at 3, comma 7 because I added 7 on the outside of that function, so it moved it up. So vertex form is essentially the following. It looks like f of x is equal to a times the quantity x minus h squared plus k, where the vertex is h comma k. If your a is positive, then that quadratic opens up. And if a is negative, then that quadratic opens down. Okay, so it's really easy to read off the vertex and tell whether it opens up or down quickly on a function in vertex form. So we like to put functions into vertex form, and we're going to do that by completing the square. So let's put the following. Let's go with f of x is equal to x squared minus 10x plus 4 into vertex form. So what I'm always going to do first is I'm going to look at this first part, the 2, and I see that that is not a 1. So what I'm going to do is I'm going to factor that out of the first 2 terms. So if I do that, then I end up with 2 times the quantity x squared minus 5x, and then the plus 4 is just hanging out. Now, then from there, I'm going to take my b, my new b, which is now negative 5. I'm going to divide by 2, and then I'm going to square it. So this is 25/4. That's going to be my magic number. The difference this time, as opposed to when we were solving quadratic equations, is I don't have another side of the equal sign to add it to. So what I'm going to do is I'm going to add it, and then I'm going to subtract it right away. So I'm going to add 25/4, but then I'm going to subtract 25/4 right away inside that parentheses. And you can see that this part right here, this is really equal to 0. So all I've done is added a really fancy 0, so to speak. Okay? Well, this part is the part that is the perfect square. So I want that. So 2 times the quantity x squared minus 5x plus 25/4. But I want to get that minus 25/4 out of there. But what you got to remember is that really this 2 is attached to it as well. So this is plus, if I bring it out, it's plus 2 times a negative 25/4. And then I still got that other plus 4 hanging out. Okay? So this part is the perfect square. And just like with completing the square, it always factors into x plus whatever the b over 2 was, which here's my b over 2 on the inside here. So that's a minus 5 halves on the inside. And then doing some algebra over here, the 2's cancel. So I have a 25/2 now instead of a 25/4, and then a plus 4. And I would like to combine those last 2 numbers. So I have 2 times x minus 5 halves, quantity squared, a minus 25/2 plus 8/2. Gives me 2 times x minus 5 halves squareds, and then a minus 25 plus 8 is a minus 17 halves. So there it is in vertex form. It opens up because the 2 up front, this guy right here, is positive, and then the vertex is a 5 halves, because it's always the opposite sign in there, and then a minus 17 halves. Okay, let's try one more. How about, let's go with f of x is equal to negative x squared plus 4x plus 3. Again, I want to have a leading coefficient of 1 out front. Right now I have a negative 1, so let's pull out that negative out of the first 2 terms. So I have a negative quantity x squared, now minus a 4x, because again, I pulled that negative out. Negative times a negative will give me a positive. And then I'm just leaving the 4, or excuse me, I'm leaving the 3 all by itself. So now I'm going to complete the square on the x squared minus 4x part. So I take that new b, which is a negative 4, divide by 2, and square it. Negative 4/2 is a negative 2. Square it, and I get 4. So 4 is that magic number. So I'm going to add 4, and then I'm going to subtract 4 right away. Because again, really, this plus 4 minus 4 is like adding 0. It doesn't actually change it, it just changes how it looks, which is the goal. The first couple of terms, which is x squared minus 4x plus 4, that's going to be my perfect square. But then I have to get this negative 4, this right here, negative 4 out of there. So don't forget there's a negative 1 also attached to it. So I have a negative 1 times a negative 4, and then there's that plus 3 still hanging out. So inside here, this factors into x minus 2, quantity squared, and then we have a plus 4 plus 3. That gives me a plus 7. So that negative up front tells me this opens down. The vertex is at 2, comma 7. So if you were to draw a graph of this real quick, here's, so let's say 2, comma 7, give or take, is right about there, and it opens down. So it'll probably look something like that. I'm not certain exactly where it hits the x-axis or the y-axis. You could add in those details, but this gives you a really good idea of roughly what that graph looks like. So that's completing the square to get it into vertex form.